the matrix.
So I see Wednesday.
17th of May, all right. 17th of May. All right, I want to take a look at what you all have around that. 17th is a what? It's a Wednesday. It's a Wednesday for real, okay. All right. All right, so let's start, right? So today we want to take a look at time graphs, right? And you want to focus on these two types of time graphs. The first one, right? You have a a distance or displacement time graph. Most times in maths is a distance time graph. And we have three shapes that we need to understand. We have one shape, right? A positive gradient, horizontal, and a negative gradient, right? I'm going to explain what each of those lines represent, right? And then you could also have, right, too small, let's see it. And you could also have a velocity time graph, and we're going to explain the shape. Right. Who can help me out here? What are some of the important things that we can read off a distant time graph? We can definitely read up gradient, right? What does the gradient for time graph, for distance time graph give you? Speed, right? So speed. So if you find the gradient on a time graph, a distance time graph, the gradient will be speed, right? What you'll notice here, gradient is positive, here is negative, here the gradient is 0. That's okay? Anybody can tell me what is happening on the horizontal part? So the horizontal part of the graph, what is happening there? If the speed is 0, it means that you are what? You're not moving, right? Right? It means that you have rest. So the horizontal part of the graph right, indicates stationary motion. Well, sorry. Indicates being at rest or stationary. All right. So that horizontal part is represents a person at rest, right? Right. Physics people. What does the positive to negative sign represent? So the speed positive, well, the velocity positive, then all of a sudden the velocity became negative. It was a displacement time graph. A change in direction, right? All right, so good. That's something great to remember, right? There's a change in direction when the sign goes from positive to negative. What about the area under the graph? Anything? Anything area under the graph? None of distance time graph, right? And a velocity time graph. It was a trick question. Yeah. There is no area under the graph here. Right? No area under the graph. What about velocity? For a velocity time graph, what does the gradient give you? Acceleration. Right? Here we have positive acceleration. Here we have negative acceleration. Well, what do you call negative acceleration? Right? We call it deceleration. What about that horizontal part there? Constant velocity or constant speed, which means no acceleration. Is the object moving here? Is the object moving there? Yes, moving, right? And one last thing, what does the area under the graph give you here? right? Distance traveled. All right, so that's some of the things that we need to remember about velocity time graph and distance time graph. I'm going to give you two formulas. Speed is distance over time. And area of a trapezium is half the sum of the parallel sides by the height. Right? So sorry to write so small there, right? But the area of a trapezium is half the sum of the parallel sides by the height. Half the sum of the parallel sides by the height. All right, so what we're going to do is we're going to practice some questions on this. When I see in there, tell me now, and I kind of small.
Yes.
Speed equals distance on time. Speed is equal to distance on time. So these are some of the things that we need to know, right? And we're going to do a couple of questions on this. Right, and I want to do back sets again the next day, right? Anybody remember sets good? Not really.
No.
So I'll do back sets and I'll do multiple choice sets, right? Okay, because it's coming only multiple choice, right? How much came last week? Remember?
Yeah, it was a few.
Plenty, like about 3, about 5 or 6, huh?
Probably 5 months.
Probably didn't even know. You're showing the multiple choice, it should have plenty.
Multiple choice question is that. So if I want any question, we do the one thing. Yes.
Also, it's supposed to have like 7 or 8 set questions. We do a different test. Let's check back and see. Nice. When you have 3, 9, about 4, or 9. Yeah, because they do have sets in paper too, they add a few more there. Yeah, ready? Are you ready there? So let's start doing some questions, right? Am I writing still? Oh, go ahead. Finish? Anybody writing still? Anybody writing online? Anybody writing online? No, right? Okay. Man, no writing, I'm saying. What? Where you reach?
So now I see them, or I don't see them. I know.
Yeah, that's acceleration, no acceleration, and deceleration.
No, no, that's sometimes.
Because somebody named NACL. Hold on.
There's sometimes when there's that here, right? Positive, negative, one,
Are you ready? Taking it off. Too bad. Taking too long. All right, this might cut off. Huh? I remember I sent you all this handout. Huh? So if you all find again trouble with a topic and you want to practice it home and bring it, I'll check it for you, right? All right, let's go to page 111. All right, let us start with one that we can actually read the values. How are we doing that, boy? All right, that's all. Anyway, not that popular. Right, how we doing this? How we doing this? Let me see if I can see that. So we have a speed time graph here, right? So we're looking at the speed time notes, right? Here's what we only have like 200 questions. So let's do me a favor and draw the table fast. I mean the chart. And then we'll go and answer everything. You all seen everything there? You all seen everything there? In the back? Seen everything? Well, Amanda not seeing, and Nia not seeing. All right, take a little read, and we're gonna do this one together, right? So you have a speed time graph, so you're basically looking back at the when I give you a speed of time, right? Then we'll go back. All right, so let's start. Everybody have it? I have the graph. So the values there are simple. The values there are 12, right? The maximum speed is 12. It took 60 seconds for the whole journey, right? Right. So during the first stage of the journey, the car sped up from 0 to 12 in 0.6 seconds. So here's what they did, right? They gave you the acceleration. Oh God, please tell me this working. All right, I'll just send it over. Give me 1 second, right? pen show up. When these things big enough, pen don't show up. All right, good. So page 111. Okay, so if you look here, here's what it said, right? The question wants you to find x, right? So we know here is 0, we know here is 12, and the value is x. And they told you that the acceleration is 0.6. So where on that graph am I going to put 0.6? That's 0.6 represent what? What is the gradient, right? So the gradient of this line is 0.6 meters per second squared. Okay, right? Yes. So therefore, if you find the gradient, you're supposed to get 0.6, right? So do my paper now. Find the gradient, tell me what you get for x. Okay. Right? So the question gave you acceleration at 0.6. So what you do is defining gradient, right? This point here is 0, 0, and this point here is x12. Right? Find the gradient and what you get for x. Right? Equated to what you get for x. Online, you can message, right? Take your time. Find the gradient. I'll do that now. And then you keep why, everybody understand why you're going to 0.6? Question? Sure? No, it's not. Right? Look back at the speed time graph. What does the gradient give you on a speed time graph? The notes that I just write down. Huh? The gradient of a speed time graph is what? Or velocity time graph. But now we can use it in the to give you acceleration. So therefore, if they give you the acceleration as 0.6, it means the slope of that first stage there, that's 0.6. So that's the reason why we like the gradient equal to 0.6. Right? So now you have to take your time, find gradient, and then solve for x. Any answers?
Yes, and all this.
Right, so I formula there for you. Those who right, so plug in the values. Let's see what you get. This is 0.6. Right, y2 is 12, y1 is 0, x2 is x, x1 is 0. Right? So you have 0.6 over 1 is 12 over x, cross multiply, and you'll get 12 is, and you'll get 0.6, x is equal to 12. X is 12 over 0.6. All right, let's check and see what online have. Nice, good job. The answer is 20 seconds, right? take a look at the unit on the graph, right? Side pattern. All right, so that's 20 seconds. What do you ask us in part 2? Are you writing? Finish? Right, part 2. Part 2, they want what is the gradient in the second stage and what does it mean? And part 3, calculate distance traveled in the third stage. Right? So part 2, what is the gradient in its second stage and what does it represent? You didn't matter work that out. What's the gradient in its second stage, Caleb? Gradient is what? In the second stage. A horizontal line. What's the gradient? 0. So the gradient is 0, which means what? No, not a speed time graph. It means something else. Check back fast. Check on a velocity time. It means constant speed, which no acceleration. All right. So you don't have to work it out. So the answer for part 2, the gradient is 0 with a horizontal line. So the gradient is 0, and the car is moving at a constant speed. Gradient is gradient is 0, and the gradient is 0, and the car is traveling at a constant speed with no acceleration. Constant speed with no acceleration. Constant speed with no acceleration. Last one is find the calculated distance traveling to the stage. How are we doing that? Right? So if you look back at how to find distance on a speed time graph, you're basically finding the area here. Right? Find the area there, please. So the distance is the area, right? Try that, please. Any questions online? I'm Diego. Any questions? All right. Find the area, message your answer. Take your time, find the area. What's the area? What triangle again? Half base by height, right? Very good. Half base by height. Work it out. All right, let's see. So it's half. The base is 60 minus 25. How much is that? 35. So it's a half by 35 multiplied by the height, which is 12. How much is that? 210. 210. Nice. 210 meters, right? Let's go again. Any questions here? Alina, you okay with us? How are we doing this way? Oh, the last one was 2011. This one is 2010. All we need to, or like a sketch graph fast, or take a picture, anything you want. You can draw it fast or take a picture of it. Take a picture or anything you want. Take a picture so you will have it to use, right? Those who would like, just screenshot it and save it. I remember you could also just join the class, right? Well, no, you can't join the class. But join it fast if you don't have a. Hey, use your phone now, so you'll get all the bars underneath, and now you don't need all the bars underneath. What type of graph is this? What type of graph is this? Speed time graph, right? So it's following all the rules for speed time, right? Can I change? Yeah. You have it changing, right? Everybody have it? Yeah. All right, so go. You'll need the graph first, so go ahead. Do your thing there. I'm giving you a few minutes and then I'll go through it with you. Anybody lost? You're just using the information. Right? So. You need the values, right? Go ahead. That fast.
B is 4, C is 102, D is 0 to 6, E is D is 2 stage, and F is 6 to 7. All right, nice.
Come on, do it out. You like to sit down and do nothing. I want you to try it out. Right, last 2 minutes and I'm correcting it. Those who online send the answers now, please. Yeah, well, later on tonight. All right, so let's take a look at it. Ready? Right, so let's go to the graph. Nikolai, I get you. All right, so help me the first part, Nikolai. From the graph, what's the maximum speed? 12, no, remember 12 meters per second, right? Look the SI unit up here. Right, 12 meters per second, right? So the maximum speed is all the way up here, 12. Everybody okay with that? The number of seconds where the speed is constant. So speed is constant is the horizontal part. What answer you got there? Right, 1, 2, 3, 4, 4 seconds. Right? The total distance covered by the athlete during the race. how we getting the distance, total distance travel, Christopher? Huh? Which saying you do that yet?
Right, plus
Wait, no, just tell me how to get it. How you just get the total distance travel? It's a velocity time graph. How you doing that?
that's it, area trapezium.
Right, so it's the area of this trapezium here, right?
Yeah.
Which is half the sum of the,
Outside.
nice, and the values are what here? 13 and 4. And the height is how much?
12.
Nice. How much it work out to be?
4,472.
2
4 divided by 2. 102.
102? 102 meters, right?
Yeah.
All right, nice. Next one. All right. Yeah. Everybody okay with that? Yeah. Richards, you okay with that? Azaria? Christian, what are you doing there? Do I have a message, man?
All right.
Right. Part 2. During the time period of the race, during which time period of the race was the speed of the athlete increasing? So look at the graph. During which period was the speed increasing? From where to where? From the first part, but what time? From 0 to 6 seconds, right? Next one, the speed of the athlete decreasing. Which one here? Third stage. Well, they didn't have stages here, but from what time to what time? 10 to 13 seconds, right? And the acceleration is 0, which part? What time? 6 to 10. All right, nice. Everybody okay with that one line? 6 to 10 seconds, right? Petal, you okay with that? Caitlin, sorry. Caitlin, I get you there? All right, good. Let's see if we can squeeze in one more. Actually, here's what. Let's try one of these. No graph, but you have to find speed and time and thing. Try this here. Right, it's not time graph question, but it's a speed, distance, and time question. Go ahead. Let's take a little read. Let's see if we can answer this here. Right, so you have a bus schedule here. It begins its journey in Bellevue and travels to Sharkville and ends at St. Andrews, right? So it starts at 6:40, reach it, Bellevue. Anything, just okay. Right, so it starts at 6:40, reaches 7:35, leaves at 7:45, and reaches at St. Andrews. So how long did the bus spend at Sharkville? Sorry? How long? 7:35. Sharkville, right? How much? 10 minutes, right? So 7:35 to 7:45, 10 minutes, right? Also, I saw in a year, right? Here was AM and here PM. So something get wrong. Look out for that, right? So 10 minutes. Nice. How long did the bus take to travel from Bellevue to Shadville? Oh, okay. How long? From Bellevue to Shadville. Right? So here's 20 and 35, 55 minutes. Very good. One mark things, right? Are you okay with that? Hey, are you playing cards there? Part 3 of it. The bus travels an average speed of 54 kilometers per hour. Look at the SI unit here. The SI unit is what? Kilometers every hour, right, Nikolai? Kilometers every hour. Right, from Bellevue to Shadville. Calculate in kilometers the distance from Bellevue to Shadville. Try that, please. Patrick, Ivan will help tell us what to do in 2 minutes. Use the right formula and the right SI unit, right? What's the which one we're going to go? Right. Pay attention to the SI unit, right? I'll check it out. Take your time. They want in kilometers. So what's the formula you're using? Speed is distance over time. So distance is speed by time, right? Equal the time it makes it stop because the formula. Right? So distance is speed by time. Look back at the little video we have there now. Hello, drop something today. All right, let's see how it went. So we said that I do it in corner here, right? We said that distance is equal to speed by time. The speed is 54 kilometers per hour. So that means your time has to be in what? Your time has to be in hours, right? So if your speed is in kilometers per hour, your time has to be in hours, right? So 55 minutes in hours is what? How you convert 55 minutes to hours? Any ideas? How you convert 30 minutes to hours? 30 divided by 60, right? So how you'll convert 55? Very good, Keshav. You divide by 60. That's okay? How much is that? 54 by 55 all over 60. That's how you have that already? No. That's a message, by the way. How much? 49.5. Hey, you work it out? 49.5 what? What's the SI unit? No, just kilometers, right? Because it's distance. All right, nice job. Let's go again. Let's go again. Oh, what year it was? Jan 2012. Last one here. June 2015. June 2015. Try that, please. June 2015. Try it. I will see some work in your book. If I don't see any work in the board, and come on.
Next.
June 2015. Yeah.
Does not current above ever be current law? Because of course, two of us are very
Right, let's go again. Time can pop in your brain. All right, let's try it now. Yeah. All right, let's see. Let's see if right. Let's see if we could depuffle the conpuffulation. Right. So we have a speed. We have a speed is 54 kilometers per hour. Right. And they told us they wanted distance traveled when the time is 2.25 hours, right? So that's 2.25 hours. So we now to find distance. Distance is equal to speed by time. So that's 54 multiplied by 2.25, which is? Huh? No, you don't have to. What's a unit? What's a unit? Kilometers per hour. So the time is already in hours. So you leave it as 2.45, right? No, you can leave it because it'll be in kilometers. 121.5 kilometers. Should be together. 121.5 kilometers, right? Are you okay with that? Right. Vishal, need a little help here. Calculate the time in seconds now. It will take to travel 315 meters, given that 1 kilometer per hour is this. So here's what they want you to do. Oh no, sorry. You can help me, please. What to do, Vishal? I don't know. So where I tell you, how could you help me? Could you help me, please? How do you get up? 315 over 500. No, that 5 on 18 telling you that for every 1 kilometer per hour, Elena, for every 1 kilometer per hour is 5 on 18 meters per second. So basically what they're asking is convert the kilometers per hour to meters per second. So you have to take the 54 kilometers per hour and convert to meters per second. And they told you how to do it. Multiply by 5 on 18. For every 1 is 5 on 18. So 54 is 54 by 5 on 18. Right? That'll be the value in meters per second. So this speed is how much? 15 meters per second. Now we could calculate the time. Time is equal to distance over speed. So the distance is 315, correct SI unit, and the speed is 15. 21 seconds. Right, let's check online if anybody got that. Good job to Visha, Naisha, Dimitri. Who else get? Anybody else gets? So far, Siddharth will get. Very good. Right, for those who didn't get, y'all follow what to do. Keshav, Kiran. Everybody okay with it? No? So the main problem here is that you must work in the same SI units. Basically like a physics question, right? If your time is in seconds, your speed has to be in meters per second. All right? So it's very important. All right, you all did that badly, so let's take our next one. Yeah? Who says so? Justin, you? You got Josiah. Oh, you wanted it? Oh, sorry. Go ahead. Go ahead. Finish? Yeah, or just now? Yeah. Right, let's see if we can squeeze in one more there. Last one. Oh, I like this one because it didn't give you how to convert it. June 2013. Last one here earlier. June 2013. 4 marks, so I'll give you 4 minutes. Try it quick, try it quick. Last one. Kavish, are you done? You done? Vishal, you'll be helping with this one here. You shall be helping me with this one here. Who's up? Right, Vishal, help me out here. Right, Vishal, the speed here is in what? Right, so the speed is in kilometers per hour. How we converting from, wait, the same thing? How we converting from kilometers per hour to what they want? Sorry? Vishal, but you just do it in the last question. I do it in physics too. How you convert isn't it the same value as well? Look back at the last part and it's the same value. Same speed, right? Yes, Mr. Vishal. How we converting 54 kilometers per hour to meters per second? By? Check the last question. I multiply my 20. You just converting from kilometers per hour to meters per second. Look at the last question and tell me what you did. Anybody can help him? How to convert from kilometers per hour to meters per second? Right, multiply by 5 over 18. We just do that here. That's a general thing. Right, or you could multiply by 1,000 to convert to meters and then divide by 3,600 here. And the answer was what again? Answer was 15 times. So the last part, they wanted distance in meters, right? How you find distance again, Nikolai? Distance is what? Speed by time. And the speed is 15. And the time is? Right, now we can multiply each other. 15 by 20, and again, 300 meters. Everybody okay with that? Yeah? So nice. That is it for your time graphs, right? Sorry?